Hey guys, and welcome back. Today we are going to talk about quadratic transformations, and then that is it for this week. Tomorrow we're going to practice everything we've learned this week and just kind of put it all together. Okay, so quadratic transformations. We have our parent function. This goes through 0, 0. It's just 1, 1, it has a point. 2, 4, it's got a point. Negative 1, 1, it's got a point. Negative 2, 4, it's got a point. So this is our parent function. So anytime we're talking about transformations, typically we are talking about how did they move away from the parent function. Sometimes it'll tell you if f of x is x squared minus 2 and g of x is 5x squared plus 4, how did the graph transform? So you have to know that you went from f of x to g of x, and how did it actually move? Just graph both in your graphing calculator and then describe the movement that happened, and that's it. So here we go. Example 1, we have x squared plus 2x minus 4. So I would put this into my calculator, get a graph, which I've already done. And now you're probably like, okay, so what do I do now? So the vertex of my parent function was at 0, 0. So I'm going to move this. I see that I moved 2 spaces left and then 5 spaces down for my new vertex. Also, I know that my parent function has a point at negative 1, 1 and 1, 1. So it's about 2 spaces wide. So I'm going to move this and see, are they about the same distance away from each other? Yes. So it didn't stretch or shrink. All that happened was it shifted to the left 1 unit and shifted down 5 units. So now we're going to talk about stretching and shrinking. So our original parabola will look like this, like a nice little smiley face. And then we've got a vertical stretch. So it kind of like extends and it gets smaller in this sense. And then we've got a horizontal stretch, which is like this. It just gets bigger, okay? So here are some examples of a horizontal stretch and a vertical stretch. So see what I meant? So this would be one of those ones, f of x equals x squared minus 2. So I would graph that first in red. And then I would see y1 of x equals half, parentheses, x squared minus 2. Now, in your calculator, you are going to notice that all of your functions are going to say f1x, f2x, f3x, f4x, which is, that's okay. They all mean the same thing. On tests, papers, we typically put f of x, g of x, h of x just to show the difference, but they all mean the same thing. They all mean that the graph is a function, and that I could essentially pull up a table of values and find all the matching points. So if you notice on the horizontal stretch though, your A is typically a fraction. So if you see already that your A is a fraction, you know it's going to horizontally stretch, okay? On the other picture, a vertical stretch, so this way, you're going to see that A is bigger than 1, so it's getting skinnier, okay? And that's pretty much it. So good luck. I wish you the best.